So moving now to our next talk. Just make sure I'm reading the right one. That's going to be our keynote speaker now. That's our second keynote speaker. It is Dr. Carrillo Melgarejo. Dr. Melgarejo received his bachelor degree in electronics and electrical engineering from San Marcos National University in Peru. His master's degree in electrical engineering from Pontifical Catholic University in Rio de Janeiro in 2004 and 2008, respectively, and the double doctoral degree from Lappenranta, Latin University of Technology in Finland, and the State University of Campinas in Brazil in 2023. Between 2008 and 2010, he contributed to AIMLis, standardization in Nokia in Brazil. From 2010 to 2018, he worked on the design and implementation of customized solutions for cellular radio networks based on 3GPP technologies at CPQD in Brazil. And nowadays, he's a senior standardization specialist at Nokia in Finland, where he is contributing to the specification of 3GPP standards for 5G advanced and 6G radio networks. In addition, he has leading the IEEE signal processing chapter in Finland since 2023. His talk is going to be about insights on 3GPP, standardization on 6G, how AI and ML are shaping the radio interface. Professor Dr. Carrillo, please, the floor is yours. Thank you.
Thank you, Luciano. So let me. Okay, nice. Okay, good morning. First of all, I'd like to thank you to Luciano and all Inatel to invite me. Beforehand, I'd like to tell you that it's not a technical presentation. You will not see performance evaluation. You will not see equations, that complex equations in the receiver side, transmitter side. But what I'm mostly doing here, I'm sharing a little bit my experience in 3GPP, which I guess usually is not common to hear in this type of presentations. And my main target is to motivate undergraduate students, postgraduate students to check another options, maybe a potential field where they can invest in the future also. But okay, I like to tell you that I'm not going to talk about details of 6G in terms of waveforms. I will not say that DFT, SOFDM, and CPOFDM will be reused for 6G again. I will not talk about coded channel, also the initial access. All details that are common in physical layers are not part of this presentation. My main focus is to talk about AIML, how AIML was shaping the 5G advanced spec, and how it's been shaping the current discussion in 6G. Okay, so I was checking yesterday the agenda. I have an updated version, but I guess maybe we couldn't update it. I will skip some sections because there are a lot of slides, but in general, the idea is I will talk about these insights of the standardization in general to show you how 3GPP is dealing with the specification. Later, I will try to talk about, probably I will skip section 2 because maybe other presentations are really done it. Here I was trying to motivate why 6G is being studied and standardized today. In the other section, maybe I will talk about that famous term in 3GPP, 6G day one. So what will be deployed in day one in 6G, which is expected to be at the end of 2029. And at the end, maybe here I will try to invest more time. I will talk about how AI is shaping the RAN access network. No? Here I will talk about the use cases that are already standardized in 5G advanced, but I will deep mostly in one use case that I was involved with 100%. It's positioning by AIML. So there are some details I like also to talk about, some aspects related to 3GPP based on my experience. So I guess that will be interesting. But okay, in general, I like to motivate your interest in standards, because standards is almost everywhere, in almost everything. There are standards for food standards, data protection standards, project management standards. Maybe you know some of them: Scrum, PEN books. These very famous international electrotechnical standards like IEEE, IEC, SIGRE, etc. All of them involved in many applications, many technologies, many services. But as well, we have these very famous standards in wireless communication, all of you know. ZigBee, Bluetooth, Wi-Fi, I guess the most popular one. But also in cellular networks, we have 5G, 5G Advanced, 6G. All of them, they have a similar target. They like to promote the interaction of different entities to have a common framework, basically. But now, today, I will talk mostly about 3GPP, because these standards, specifically the ones related to cellular networks, are done by 3GPP. But okay, it is another order. But let me skip here very quickly. Okay, there is a mobile communication landscape. It's mostly defined by these three main entities: standards, market partners, and regulators, and there is an interaction between them. So that is why that usually 3GPP, the decisions that are done in 3GPP are not easily to carry on, because it's not only about technology. It's about politics, it's about economy, it's about geopolitical aspects also. So it's a very difficult scenario. That is why that I was reading a lot in the social media that companies are saying that 6G it will not be a new generation. It will be only an enhancement of 5G advanced and nothing else. Yeah, probably they are right. Probably they are not right, but it's not because companies like it. It's because usually there are important opinions from operators that they are mostly they have their long-term plan and they have investments that they should take care. But in general, the idea is there is an interaction between these three elements. You can see here Inatel is one of the main regulators around the world. They are mostly defining requirements and input specifications for 3GPP. The markets partners are mostly defining common views on spectrum allocation. There is a very important discussion in ITU about the frequencies that will be used in new generations, like 6G now. And also the operators, they usually have a very close communication with the companies that are participating in standards to define the common views on use cases and technologies. So there is a synergy between them. So that at the end, based on this synergy, it's possible to generate these standards. 3GPP is mostly based on these standard development organizations. All of them are representing very important countries around the world. We have here, for example, US ATIS, Japan TTC, and other important countries. All of them at some point are representing companies, operators, countries, regulators that are part of these 3GPP meetings. Okay, I will skip this. I guess it was discussed a lot, but in general, 3GPP was developing all of these generations, now 6G. But maybe the most important thing now, let's talk about the way that 3GPP works. Usually, the participants are persons like me, but we are not representing ourselves. We are representing companies. So every word that we are saying in these 3GPP meetings, they represent a lot. It could be against or in favor of us also. So we should take care a lot. And But in addition, there are many companies that are being represented, also ministers, regulators, and also vertical industries. An important thing, the way of working, it's a face-to-face meeting. You can see here in this picture, there are a lot of people, usually less than 1,000. There is an active discussion. There is a proactivity and contributions for every company. But the important thing is that decisions are based on agreements by consensus, which means that we should be capable to convince to the other delegates from other companies if I like to push my concepts. So there is a game here to how to convince people using technical arguments, using non-technical arguments, etc. But the important thing is that nobody should say no. The guy who is dealing with these decisions and these discussions is the chairman, who is the guy. He has the power there. So it's a nice experience. The income I commented before, these are these operators, these regulators, etc. But the outcomes are mostly the studies, the work items. The studies are mostly the process where many technologies are analyzed, many technologies are evaluated. That is why it's important that companies should be able to build their own simulator. It should be very flexible also, because you need to simulate scenarios that other companies are proposing. So in that way, you can say, okay, that's a good idea, or it doesn't make sense because the performance evaluation is showing a very bad performance. So with that arguments, you can go to the online meetings and you to say, oh, no, that is not working, or yes, it's okay. So there are the frequency is mostly between 15, 24 months per release. There are a very well coordinated plan. I can say that to deal with many topics, to deal with many people, the work that these guys like the chairman, the vice chairs are doing is amazing. I don't know how they survive the whole week, but this is really surprising. Okay, but here, these pictures, I took these pictures the last week. This was a session of AIML. If you check, the way to work there is to hands up your hand and try to be extremely dynamic with your opinions, because if you say something, immediately other company will provide an argument against you or in favor of you. So you should be capable to accept also rejections. So you should take care of this. Let me open a little bit now my experience here. I have seen scenarios where people are crying also because there is a real fight between companies, especially between UE vendors and network vendors. Sometimes it's a geopolitical issue also, people from China versus people from Occident, from the West. So it's an interesting experience. The funny thing is that at the end of the week, everybody becomes friends again. So we forgot everything. So that's a good thing. Okay, now let's talk about specifically what I'm doing in 3GPP. In general, 3GPP is a huge organization. You can see here. Okay, there is the CT core. I guess yesterday we were watching some presentation of the core network. Here they are mostly discussing aspects of the protocols between the core network and the UE. There is this other important group that's SA, is the service and system aspects. They are mostly defining the architecture of the whole 5G, 6G system, including core network, including RAN, etc. And the one where I am involved is the radio access network. It's mostly related to the physical layer and the MAC layer. But specifically, I guess it's in the next slide. Yes, in the next slide, we mostly focus in the physical layer, and the RAN2 working group is mostly focusing in the other upper layers like MAC, RLC. And in RAN1, which is my main focus, we are mostly updating these specifications. And here is another point, maybe it's a disappointed point of many researchers, especially in academy, that you will see that 5G, 4G was based on top 5G, and 6G will be built on top of 5G. So our main work is mostly to update these technical specifications. So at some point, it's difficult to get a disruptive framework for AML, for example, today. Because we depend, there is a strong dependency on the legacy. So that's the weak point. That's my personal point of view, but that's the way of work here. Here you have many aspects on the spec. Maybe in another opportunity, the best way to explain you is to open in this spec and guide you, because guide all of you, because if somebody who is not involved in 3GPP and if you open these specs, you will read noise only. Unfortunately, that's another problem, because companies are not interested to expand that information in a very familiar way. But when you are involved in the topic, you really realize how to get information, how to link. I guess it's in another slide. Yes, how to link aspects that are specified in the RAN 1 specifications with the specifications that are related to RAN 2, for example. So we have MAC, RRC, LLP. For RAN, this protocol is very important. RRC is mostly based, almost everything is based on this. And there is an interaction between RAN 1 and RAN 2 to discuss if RAN 1 makes a decision that may impact in any of these protocols, RAN 1 should send a formal message to RAN 2, and RAN 2 will discuss, will say, okay, it makes sense or not. In the other side, RAN 4 will provide requirements to RAN 1. Now I realized that I guess I forgot to comment something, to comment here about RAN 4. Yes, here. We have these working groups. RAN 1, as I explained, is physical layer mostly. RAN 2 is mostly MAC layer, upper layers, mostly related to protocols that are dealing with the user plane and the data plane. RAN 3 is mostly related to, they focus mostly in protocols that are based or are developed on the base station only. And RAN 4, it's a very important working group. They are mostly, probably in my view, they are the ones who are dealing with real problems, coexistence, what should be the maximum power, what should be the minimum scenario where to test a base station in the UE. These requirements are very important, and these requirements sometimes are used as input for RAN 1. Okay, this is, I will not provide details here, but the slides will be available to you. It's important just to understand what does it mean every number. Version 17.2.0, what does it mean? I'm explaining here. One is related to the specification, to the release. The other one is how many times it was iterated from the technical point of view. And the other number is related to how many times it was iterated from the if there was any editorial problem. Here also I make a summary of the specs. I guess I don't need to detail now. This is just to give you an overview of the impact and how the companies are investing in 3GPP. Always Huawei is the company that has a huge number of delegates. I'm sorry, you are seeing decimal numbers here because some delegates are sharing 2 or 3 working groups. But in general, you can see that Huawei has a lot of delegates. I can say that Nokia is in the average. It's not too bad, it's not good also, it's not the best one. But there is a lot of investment. So I guess I commented before, there is an interaction between delegates in online sessions. The outcomes are mostly agreements. Sometimes when the release is ongoing, when the releases has ended, there are some change requests. That mostly means that you know the spec, but you identify that there are some gaps in the spec that are not mapped yet based on previous agreements. So you will propose a change request in the spec, and you should provide a text that needs to be included in the specification. And that's why that we use this term, very popular name, change request. But in summary, we have the input are based on the contribution, based on these TDocs. That's why that usually 1 week before every meeting, there is a deadline, and companies should submit their technical contribution, exactly as you were submitting papers in conferences, etc. And you have 1 week of gap of 1 week to study the other TDocs from other companies. So every company prepares themselves to say, okay, I identify that Qualcomm is proposing something that maybe I'm not aligned, or maybe I may be aligned. And based on this, a whole team of back office is supporting delegates to identify these issues. In the meeting, usually the delegates, we start to talk with delegates from other companies. We ask questions, we ask clarifications in case we are a little bit aligned. Or if we are not aligned, we also make questions to know if they really have a good argument to defend themselves. Yeah, I guess that's okay. This is also, maybe just 10 seconds. This was the meeting schedule of the last week. If you can see here, we have 3 parallel sessions online. Most of these whites, I guess you cannot read, but all of them are related to 6G. AIML was discussed, for example, on Tuesday and also on Thursday. But all other topics for 6G were discussed. In parallel, there are these offline sessions. These offline sessions is very specific for round 1, because round 1 is a huge working group. So the chair, he selects, also that's political, the chair selects specific companies, and these companies will lead a pre-discussion of one specific topic. For example, AIML was in charge of Samsung, and Samsung delegates, they do a summary of all company contributions. There is an offline session. In these offline sessions, companies can say, okay, yes, I agree or not with that summary. And that summary later is raised to the online session and to make a final decision. So it's a very busy week. Now let me open my own experience also. Maybe if you are not involved in the topics, it's extremely boring. Extremely boring. But if you are involved in the topic and you are really raising your hands, targeting with one specific target, which your own company will define for you, it's fun, because you really will fight. You will really. It's like a game. When you will win, you will feel very, very well. But sometimes you lost also. But that is part of the game. But in general, the interesting thing is that your networking is increased exponentially. I have worked here in Brazil, also in Finland, in Peru, but my networking was increased here in a way that I have never expected like this. So that's a nice experience. But okay, I'm not sure if you have any question about 3GPP. Christian.
It's just a curiosity or clarification. So it's online and offline, the discussions, or just in the room, face to face? That was not fully clear to me.
Yes, I will clarify. Yeah, there is, usually if you have, here you can see AIML is usually before the online session that we had on Tuesday. It was on Monday and Tuesday. There are different rooms, usually small rooms. Here, we can say it's a kind of pre-agreement. Even that you are not aligned, you can raise your hands and you can say that, no, I don't like it. Happens to me many times, but the chair can say, only one company saying, no, only Nokia. Sometimes he forces you to say, I will write here that only Nokia doesn't agree on this, and this decision will be raised later in the plenary. I forgot to mention this. I'm participating in this working group, 3GPP meetings. There is another level of meetings. It's a kind of a steering group meetings. The big boss of every company are participating there. They don't talk about any technical aspect. They are mostly talking about these political aspects. Usually the chair say, Dick, your name will appear there. You are talking about 6G AIML, and if you say Nokia, my boss will ask me later what happens. So I need to know also if it really makes a sense to reject a topic from Nokia point of view or not. So that's usually that's part of the game also. Yeah, but yeah, in general, you have a different room in offline sessions, usually before the online sessions. And also there are ad hoc sessions that can raise based on, usually you can see here it's empty. Usually the chair, because there are topics that are very difficult to handle. Usually Friday is used for this. But again, as much you know other delegates from other companies, the interaction, the synergy is enhanced also. So yeah. Okay. Yes. Okay. I was checking my cell phone. I don't have so much time. Maybe I will skip this section. This was the motivation that maybe most of the previous presentations were done. Very high level view from Nokia also. I guess that's very popular. But now let's check a little bit about 6G day one. What is expected? In general. It's a cycle, no? It's a process that probably for 6 years started 5-6 years ago with the research and vision formulation with probably many of your papers you and other research centers around the world were doing, and all of these technical contributions, academic contributions are used as input for these research centers of each company that are participating in 3GPP. Or also like Nokia Bell Labs, they do their own research and based on the analysis and based on the implementation team at Nokia, they decide what technology will be pushed, in this case for 6G. The next step is to standardize. There is an industry consensus, is mostly in another word to say 3GPP meetings, etc. When the standardization is achieved, there is a phase the 6G trials, and then last step is probably the 6G commercial launch. Here there is a note that it was, I guess, this year the first 6G workshop meeting happens. Yeah, now it's past. But maybe in this timeline, I will give you an insight of what is coming. The release 21 will be the release that will show you what 6G will be. That's what we are discussing now. If you can see, the first step was already done in 2023. The time plan was set. This 6G workshop that I commented before happens at the beginning of this year. The study of 6G started in June and July. And the standardization, the final standardization stage should be done at the end of 2026. It is expected to have the final release will be frozen in December of 2028. And as I commented before, the deployment is expected at the end of 2029. I will skip also this. There are so much information. I like to focus mostly in the other topics. Maybe here this summary of the previous is the best way to go ahead. What will be bring release 21 in 6G day one? It's mostly a performance evaluation should be there, setting a new benchmark to meet future demands efficiently, scalability and monetization. It's a high-level summary. It's involving not only RAN, it's also involving core, and also ensuring environmental responsibility and building cybersecurity and resilience. But from physical point of view, physical layer point of view, maybe the main technology enablers will be that we are planning to go ahead in this direction, AIML native framework. I commented yesterday with some of you that non-terrestrial networks are very strong also in 6G. Maybe one of the key differences. Enhancements in massive MIMO. That was the best feature of 5G. It for sure will continue in 6G. And the other aspects that are mostly related to the core network, programmable networks and API native, this environmental sustainability framework that mostly is related to the energy efficiency, that is another very hot topic in 6G today. And this is an important one, a single architecture and a smooth migration. In 5G, we proposed, not we, but 3GPP proposed 2 different architectures, standalone and non-standalone. That will be avoided. That was the main concern for operators, and they mostly conditioned vendors to avoid this scenario. So it will be a single architecture this time. Okay, now let's talk about what I really, maybe I like to extend a little bit in this presentation. Here is a detailed timeline, but here we included 5G timeline and also 5G Advanced and 6G. The important thing is that 5G Advanced was starting from release 18, was the first specification that includes AIML in the specification. Before, everything was done by implementation. It means that probably Qualcomm already implemented AIML in their devices, but it was done by their own. The data collection was done using their own systems to do it. The monitoring, and nobody knew it, and nobody needs to know it also. So the same thing happens probably with Nokia, with Ericsson, etc. But since 5G Advanced, now there is a framework that is enabling these specific steps on the life cycle management of models using an AIML. That is why that based on this experience, the 6G study started. There was a technical report wrote in the study done in release 18. That is the base to this 6G study. And now in the timeline, you see here that we started, one important point. Since August until the last week, we were doing a kind of pre-study. In AIML, from AIML point of view, we were selecting several use cases for AIML. There were a lot. There were around 28 use cases. The problem is that only 2 or 3, they have a very huge support of majority of companies. The other ones were mostly having 1 or 2 companies. Here is another political aspect. Our chair decided this time to not down select and to generate a new agenda item since February. And all of these use cases were spread in non-AIML topics, and each of them should be able to survive now in agenda items that will be linked to non-AIML. It means that the target will be during the performance evaluation to compare to say, AIML is doing better or not than non-AIML. So that will be the main argument to do the down selection. Again, that is a political direction. Other approach would have been to say, okay, I will define an agenda item only for AIML in parallel to the non-AIML. So the outcome could be different also. So maybe I didn't include here also another important aspect of 3GPP, how these chairmen are elected. So that also is a key point in general. But maybe I will include it in another presentation. Okay, the important thing is that the real study in 6G will start in February of the next year. We will have the whole year to finalize it, and at the beginning of 2027, we will start the specification. So the specification should be ready before 2028, probably, the end of 2028. And the deployment It's here. Yes, at the end of 28, and the commercial 6G deployment before 2029. Okay, now a more detailed timeline, but for AIML only. AIML is not new for 3GPP in general, but it's new for physical layer. If you can see here, we started the study in physical layer in 2022, or the first work item or the first specification was done in release 19. There are 3 use cases that I will focus now a little bit later. And now we are in the study step and specification, as I commented before. But AIML was already studied and standardized in other working groups. In the core network, there are functionalities dealing with AIML, also in the base station, etc. Okay, now let's go a little bit. This, maybe I will skip this, but in general, this is the main motivation to use AIML in wireless. Usually we are using CNN, DNN, etc. But one important aspect from 3GPP point of view is the location of the model. The model could be located in the UE, could be located in the Keynote B, or it could be located in the cloud. That looks very simple, but that means a lot for the specification, because each of these scenarios will define a specific specification, will define or simple or hard specification impact. So that was a common discussion during the studies and during the work item. But okay, going, I guess it was not exactly as I was sharing, but the idea is that one important outcome of the release 18 and 19 is the framework of the life cycle management, which is mostly focusing in monitoring, in data collection, and also inference, and also the testing. How a model deployed in the UE side that is receiving assistance from the network will be tested. Usually that is the main task of Run 4. They are defining requirements of latency, requirements based on the use case throughput, accuracy of the position, etc. But there are 2 aspects that are new in general for 3GPP, is the monitoring in data collection. The black box that is not non-AIML, usually they don't require this monitoring because the main issue in AIML is the generalization aspects. So that, unfortunately, that is the problem, at least the conservative direction that companies decided to go ahead is to use mostly supervised learning. So we strongly depend on the label, and sometimes that's an issue, because some applications they are working very well in the simulators, they are working very well in a very controlled scenario, but when you will deploy it in the real scenario, it's complicated, and the generalization is an issue that is why that we require monitoring of the model every time. That's also another issue, because that include overhead in the signalization. But that's the case. But another problem is the data collection. As I commented before, the use cases that were standardized are mostly based on supervised learning. So the main issue is to identify the ground truth label. For example, in positioning, there is only one entity that can generate a real ground truth label. It's one entity. I don't like to deep so much, but there is an entity that maybe is only less than 1% of devices that are deployed in a network. So it's not practical. So there are many aspects that were included to generate this ground truth label that may impact in the performance, but the way that you will do the data collection of this ground truth is up to implementation. So now I like to take advantage of this to comment another experience of 3GPP. 3GPP mostly is trying to define a generic framework, a common framework between companies, but the way that one company will make a difference to support one specific feature is the optimization of that feature. So sometimes when I comment with my colleagues from universities, etc., I also advise them to go in the direction of the futuristic. That's a good approach. Another approach is to go not so much in the future, but a little bit in the present, but trying to focus on the optimization of these features. For sure, that will have more impact on industry in the near close. Maybe in less than 5 years, you will get impact. You can get not a job in a very good company, or maybe your research center can get in touch with these companies because you are specialized on optimize that specific feature. No? So in that sense, one good start point is to understand the specification. So that's a personal advice. But okay, in general, this framework facilitated the management of the functionality, which is another important aspect. In general, in round one, the main aspect is that the network should do the management of the UI capabilities, the UI features, the capabilities that will be activated in the UI. And at some point, the network is the entity who is dealing with all of these aspects, because from one point of view, the network is the entity that knows all details of the radio air interface. Okay, I also updated this slide, but it's not here, but there is a collaboration level. It was also an outcome of 3GPP study item. The collaboration level, again, we are considering here that UE could be deployed in the UE side. I'm sorry, the model could be deployed in the UE side or on the network side. But in level X, there's no any collaboration. So mostly it is what we had before release 18. Every UE vendor, every network vendor can implement AIML and nobody knows about it. You don't need to know also. Now in release 18, we introduced this collaboration level EA. There is mostly interaction between network and UE to enable AIML, but only at the signalization level. So there is mostly an assistance from the UE and from the network to the UE to provide, for example, measurements, to provide configurations, etc. But there is another level. There is, in addition of the signalization, there is a model transfer level. So there are use cases where the network should deliver some models to the UE. Now it's being discussed in release 20, and 3GPP is defining specific architectures of models that will be shared between these entities. Okay, I guess I will skip a little bit this because I talked in the previous slides, but in general, there was an evolution in AIML in general. Now we are expecting to have a well-integrated AIML features in the run. As I commented before, there are new use cases. But one important point, there is one condition that it was raised by operators. Okay, we might include AIML features, but reducing as much as possible the impact on the specification, which again is a constraint that really, in general, if you are working in the data science world, that doesn't make sense. But unfortunately, that is an issue that we should deal in 3GPP. Okay, I will skip a little bit, but maybe this is one. Here there are two use cases. Bin prediction by AIML, very well known also in the state of the art. The CSI compression, very well known also in the state of the art today. But one important aspect to raise here is that these use cases was already standardized. This use case was not standardized yet, because there was an issue on the collaboration level that I commented before. It was not clear to companies if what type of models will be delivered from one entity to another. There was also another use case. The previous one was CSI compression. This is the CSI prediction. Mostly the idea was to predict this type 2 CSI feedback from the UI to the network. It's also standardized. I will not provide details of this. Maybe now I like to focus mostly on this, in positioning, because this is the topic that I was dealing for around 2 years. It's an interesting use case. It's mandatory for 6G because it's an ITU requirement. So the main motivation was that the legacy positioning, they had an issue that is mostly strongly dependable of the line of sight. We have amazing methods for positioning, but if you don't have line of sight, you are done. So in some industrial scenarios, they were showing scenarios where with clutter density of 60%, these non-AML methods were not working. We're getting accuracy of 8 meters of error. That is so much for this. That's why that AIML got track on this using fingerprints approach. In AIML, the accuracy was improved a lot. Sometimes it was. This is one case, but I have seen better scenarios. Here we get 1 meter and 1.2 meters, but there are scenarios where you can achieve less than 0.1 meters. So it works very well. And in addition, I guess it's in the next slide. Here I'm showing a little bit what I commented before, the motivation. When there is many non-line of sight scenarios, is the best scenario where AML can do better than non-AML. And maybe again another comment about it. AML, at least in 5G Advanced, was not trying to replace, was trying to complement what non-AML is doing. So that's another important point. Okay, let me skip. I take advantage of this slide now. We have 2 directions for AML. One, when we use a direct AML positioning, you have the channel impulse response or measurements of the channel, and the output of the model will be the UE position. Here in the upper side, I'm showing the training stage, which for 3GPP is up to implementation. So it's up to you how you will train your model. It's up to you what architecture you will use, etc. But the data collection is an important element to use here because you require collaboration. If you will train your model in the network side, you will need a collaboration from the UE vendors. So that's why that we created some signalization to facilitate this interaction. Here we have the direct AML positioning, but here we have, in my view, the best scenario where we are using this AML assisted positioning. It's a kind of cleaning block. You are receiving the channel impulse response, and you estimate that TOA. This estimated TOA, when you have a huge percentage of clutter density, will be very accurate. So it's like you will transform the non-line of sight to a line of sight. So it will be a complement of the non-AML methods, which are very accurate. So you are solving the problem of non-line of sight, and usually you will get a very high accuracy in this specific use case. Taking advantage of this time, usually in the study item, you discuss many use cases, but what is the most important thing at 3GPP is to specify it. In the study item, in positioning, we had all of these 5 use cases, but only 3 of them were standardized. Again, the decision is political. For release 19, we go ahead with this case 1, with case 3B and case 3A. Case 2A and case 2B didn't go ahead mostly because Qualcomm was avoiding to do it. There was a lot of spec impact to them, and they were capable to convince other companies to not go ahead on that direction. But potentially they will come back in 6G, but not in release 21, probably in release 22. Yeah, but the idea is that now we have specified this, case 1, and case 3A and case 3B. Some of them are impacting RAN 1 specs. Most of them are impacting RAN 2 specs. I didn't give you details. Here is the performance analysis, all of them. Maybe you can see later the slides. I don't need to. Yeah, thank you, Lucian. Yeah, maybe here, again, talking about the spec impact. Positioning is mostly based on one protocol. The name is LPP. This protocol is dealing with positioning. But if somebody who was working in non-AML times, they will see, but it's exactly the same that they standardized before. And that was the outcome. There was not so much spec impact. There was only one spec impact, very strong impact, based on the generalization issue. The generalization forced 3GPP to include one signal using one container called associated ID. This associated ID is used to differentiate different models to different scenarios on different number of TRPs. So, but that is transparent to this high-level signalization in LPP. But there was a few specific spec impact when the UE, when the network is LMF or network provides assistance to the UE, and the UE will use this information to select different models. So that's another case, at least based on the study item in release 18. The idea is that the entity that will deploy AML will have several models. And based on this assistance, the UE or especially the UE will select the proper model. So it's not a clean solution. It means that we are not expecting to have a universal model that will solve all scenarios, which is an issue for AML in general. Now let's go to 6G because, okay, now it's 6G. So that is why that, unfortunately, AML for 6G will not be mandatory. It's an optional feature. So in practice means that probably majority of companies will not deploy it. Only if somebody requested, any customer requested, maybe it will be the case. But okay, about 6G, this is very fresh information. It's based on the last meeting, also the previous ones. But as I commented, there are 48 companies contributing actively, a lot of pages, many TDocs, more than 1,000 pages. The most popular use cases are probably the overhead reduction in the reference signal, DMRS, CSIRS, SRS also. There are also use cases for bin management, PIPR reduction, ARCI feedback. But now I will focus a little bit in DMRS design for AI receivers. In the last meeting, companies were contributing and were showing this configuration of the transmitter. Based on this configuration, we have a specific receiver in the other side that I will show you in the next slide. But important thing to highlight here, there are many configurations. One is when the reference signal is based on, for example, in DMRS, is based on a sparse DMRS. The other configuration is when you are using superimposed pilot. The other case where 6G is transmitting DMRS free. So no pilot. So this scenario today is still in the table, not yet any decision, but potentially my forecast is that at least this should go ahead in the specification. And the other side, in the constellation, the idea is to reuse the regular constellation that we have in 5G, but also to open the table to non-regular constellations, these custom constellations. Some companies, they wished probably to kill this topic beforehand, but it's still in the table. Let's see what will happen. And we have the RF transmitter chain here. But the important thing here is this, based on the last meeting outcome, the idea is that based on the regular building blocks of the receiver, the idea is one use case is trying to replace this channel estimation. Other use case is trying to replace channel estimation plus channel interpolation, both. It's very simple because the idea is to replace this black box, replacing these legacy boxes. The other companies are trying to replace only the channel interpolations. Other companies are pushing to replace all this change, the channel estimation, interpolation, equalization, and demodulation. And others, they like to use these joint models, one focusing only in channel estimation and other focusing only in equalization and demodulation. This was the outcome of the last meeting. Based on this, all of these scenarios will be mapped, as I commented you before, in non-AML topics. And all of these use cases should be capable to show trade-offs, benefit cost, and they will be compared with non-AML. So that is what is coming in the next meetings. And let's see what happens. A summary, in general, AIML, at least from release 18 and 19, the main outcome is this framework for the lifecycle management was defined. We have these use cases in 5G Advanced, in bin management, CSI prediction, and positioning. In 6G studies, we raised the new use cases. One of the most popular are related to reference signal overhead reduction. It has a good reason because it has also low specification impact. So that's why that is the most popular. And in general, there are other discussions that maybe will be also considered in the studies if the solution is based on one-sided model or two-sided models. I didn't have time to deep on this, but this is another hot topic to discuss between companies. But yeah, maybe another time I will do it. Just to finalize, a very important suggestion is to, if you have time, try to navigate in the 3GPP FTP server, because it has a lot of information. Even if you are writing inventions, patents, this is a very good source. It's free, and the most important thing, it's updated. All details that I commented to you are available here. It's free. But usually people don't use it because, I don't know, because it's very difficult to navigate. It's not friendly, unfortunately. But if you like my support, I'm able to help you. I really like it a lot. It's very useful. Also to write papers. You can write a paper today talking about 6G based on the outcome that we had the last week. So that at least from my point of view, that's a good start point. That's all. I'm sorry for the time, and thank you for your attention.
You were spot on the time, so no need to apologize. Okay.
Thank you for your presentation. Two quick questions. You mentioned about there is only one entity that can generate the ground truth label for positioning. Could you elaborate a little bit more on that? And number two, what's your general view on integrated sensing and communications for non-connected objects?
Yes. Yeah, that's not the topics in AML, but that's a strong topic in 6G in general. Probably that is the way to go ahead for positioning with ISAC. I was talking with Qualcomm, I was talking with Vivo, ZTE. I'm saying I was talking with them because Nokia, my Nokia back office requests me, because Nokia is also trying to get a decision on this. For sure, sensing will go ahead. Some companies are trying to go in the direction to use AML, but independent of this, it will go ahead. What it's not yet defined if they will define a new waveform. And based on this, they might define a new reference signal also. And the problem of this that it will require an additional specification impact. So that will be the challenge. But there is a lot of interest of companies. For sure that will go ahead. Now, for the PRU, the ground truth label, thank you for the question, because I discussed it a lot. I didn't provide details here because I didn't like to confuse you. The name of the entity is the PRU, Positioning Reference Unit. It's an entity that was introduced in the specification, I guess, in release 18, 16, I'm not sure. This is a regular UE. It could be your cell phone, but the difference is that the operator knows its exact location. So usually it's managed by the UE vendor, usually Qualcomm, usually Samsung, Huawei. They know the details, they talk with operator, and because this information should be available in the core network. That is why that is the unique entity that has a real ground truth. The other ground truths that were considered in the study were another UEs, and they were estimating their position. Because when there is a UE position estimation in the UE, there is also analysis of the quality of this. So this quality was used as a kind of a variance of the accuracy, and based on this, again, it's up to implementation. You will consider as label or not. Yes. Yes, what?
Right. So I was curious because what I didn't saw in this presentation is how, for example, other initiatives in AIML for mobile networks interact with what 3GPP is looking at. For example, I know, for example, that Aura Alliance has an alignment with 3GPP. It started last year. This beginning of this year, they had an initial workshop. And two areas that they decided that would work kind of together would be the open front haul, and the other one would be AIML, more specifically on what you discussed, the delivery of models and the trained models and such. Do you follow this? Do you have any information on how this is working, this integration with other SDOs in terms of AIML?
I don't follow directly, but it's not at my level of a regular employee. Usually in the steering group level, I know that they are discussing, but the discussion is only at that level. I know there is an intention to all run to collaborate with 3GPP. I know the position of some companies in favor or against this, but at the level of the discussion here in the ground, in the battlefield, it was never included. It was never included. This case of model delivery is one specific case that is the unique way to enable the CSI compression. It was very hard to go ahead because only the details of the model delivery. So unfortunately, 3GPP is very conservative. Unfortunately. I can say also Nokia, but sometimes the things can change. We don't know with NVIDIA now, many things will change from Nokia side. Yeah, but that is it. That's the way for.
Thank you, Professor, for a good
Yes, true.
presentation. I am curious to know, it is good option to replace classical algorithm with AI and ML model. And the other question is, classical algorithm are safe, secure, and no privacy issues.
Yes, yes.
And in AI and ML models, there are issue of data formatting and label preserving.
Yes, yes.
And I think if any wrong handover decision or beam switching can drop thousands of calls. if using AI and ML, how we
Yes,
can
yes.
overcome these issues?
Yes, I agree with you. That is one concern raised by operators. That's a real concern. That is why that this, if you recall in the life cycle management, I was talking about the monitoring. That's a very important feature, unique for AML. And in addition of this, that is why that AML is not mandatory. It will not be mandatory for 6G day one. It will be an optional feature only. It has advantages and disadvantages. And usually the legacy methods are not 100% accurate also. There are scenarios for positioning, as I commented to you before. When you have a non-line of sight, fully non-line of sight scenario, the legacy method is not doing well. So the same happens in the building blocks in the receiver side. There are specific scenarios where non-AML is not doing well, and probably that will be the gap that AML solutions will try to fill. Another question? Okay, hybrid models. Again, that is up to implementation. That is not part of specification. 3GPP will not handle with that details. You can do it if you know the spec. You can make an hybrid solution, etc. Yes. Christian.
Yeah, I had a question very similar to Fuad's one. So let me think if I understood your answer. For instance, AI Run Alliance, I thought that they were working together for optimization use cases, the type of AI for run, and then they would come with facilitated offline proposals converged to accelerate the standardization decision. But I understood that they are doing something that may input their individual plans, but then at 3GPP level, it's battlefield, and there is no AI run stamped change request. Is that right?
Yes, at least what I'm saying is the information that I know. I'm not saying anything else. I cannot say anything else. Also. But these guys in the top level, I know that they are receiving inputs from ORAN. There is an intention, but it's not only Nokia, it's only all of these companies, 48 companies. Nobody tried to push it in the battlefield. So if you open the T-Docs of all of these companies, no mention to ORAN. So that is a message. That's a message. Yep.
So let's thank Dr. Melgarejo once again. Thank you very much.